Hello and welcome to the live session by Infinity learned by Sri Chaitanya. I am Misbah, your maths educator, and in this session we are going to talk about the basics of number systems and the decimal representation of real numbers, that is rational as well as irrational numbers. So let's start with it. So the very first thing is the definition of rational numbers. So what is a rational number? A number which can be written in the form of p by q, where p and q are integers and q is not equal to 0. I mean any number, for example 8 by 3, that is a rational number because it can be written as a ratio of two integers. Basically rational is coming from the word ratio itself. It is the ratio of two integers. You see, this is an integer and integer. So if you're taking the ratio of two integers and the denominator is not equal to 0, then that is a rational number. Now you see over here that every integer is also a rational number. For example, you take -5, -3, 0, 5, 8, all of them are rational numbers because all of them can be written as a ratio of two integers. You see, ratio of two integers where denominator is not equal to 0. So every integer is also a rational number. Now the set or the collection of all rational numbers is represented by the capital letter Q. Basically Q is coming from the word quotient. Set of all rational numbers, it is represented by the English letter Q because Q stands for quotient. Quotient means the result of division. When you divide something by some other thing, the result is known as the quotient over here. Now you can see over here a rational number may be positive, 0 or negative, which we have already explained. So you see every natural number is a rational number, every whole number is a rational number. And you see decimals are also rational numbers. For example, something like this. This is a rational number because we can write it like this. But you see every type of decimal number will not be rational. We'll talk about it in detail in this class itself. So let's talk about the decimal representation of rational number. So you see every rational number when expressed in the decimal form is either a terminating decimal representation or non-terminating repeating decimal representation. It can be terminating or non-terminating repeating, or you can say recurring decimal. So two types of decimal representation of rational numbers are there. It can be either terminating or non-terminating repeating, which you call it recurring as well. So only two types of decimal representation of a rational number can be there. So let us understand it with an example. For example, I have got 9 divided by 8. Let us find its decimal representation. So you see over here, there is no remainder at last. So when there is no remainder at last, it is for sure that the decimal representation will be a terminating decimal representation. What is the meaning of the word terminating? Terminating means it is stopping after some places of decimal. Hi Ajit, hello Soumya, hello Anushka, welcome to this session. Is it clear? So you will have a terminating decimal representation when there is no remainder. Terminating means it is stopping after some places of decimal. For example, you have got 125.5678. This is a terminating decimal representation. It is stopping after some places of decimal. So you will every time get terminating decimal representation when the remainder is coming 0. When it is getting exactly divided, 9 is exactly divisible by 8, or you can say remainder is 0. I hope that one is clear. So then you will have a terminating decimal representation. Now you see you can have other cases as well. For example, I have got 7 divided by 3. What will happen in this case? Let us do actual division. So you will see, you will keep on doing division. You will never get remainder equal to 0. Are you getting that? I'm doing good, Ajit. I hope you're doing good as well. So you will never get remainder as 0 over here. Every time you will get remainder is equal to 1. So what does it mean? That this is not terminating decimal representation. It will never stop. Basically 7 upon 3 is equal to 2.333 and so on. So we use 3 dots for it, right? We use 3 dots for it. Now you see the part of the decimal which is repeating, we put a bar over it. The part of the decimal which is repeating, we put a bar over that. Now this bar is called vinculum. This bar is called vinculum. Is it clear? So only 2 types of decimal representation of a rational number can be there. It can be a terminating decimal representation. It means it is stopping after some places of decimal, and you will get a terminating decimal representation when it is exactly divisible, or you can say the remainder is becoming equal to 0. Or you can have a non-terminating but repeating decimal representation. It is not terminating but the same thing is repeating. So you call it non-terminating repeating decimal representation, or you call it recurring decimal representation. Recurring you can understand from the word reoccurring. It means it is occurring again and again. So non-terminating repeating or non-terminating recurring decimal representation can be there as well, and it will come when the remainder is not equal to 0. Non-terminating repeating decimal representation will be there when the remainder is not equal to 0. So only these 2 types of decimal representation can be there in case of rational numbers. Any doubt in this thing? Just confirm once. Ajit, Somaya, Anushka. Any doubt in this thing? Again, I'm repeating, 2 types of decimal representation of a rational number can be there. One is the terminating decimal representation, that it is stopping after some places of decimal, and terminating decimal representation will be there when you don't have any remainder, when the numerator is exactly divisible by the denominator. It can be there in case of a negative number as well. For example, you can have -7/8. This is also a terminating decimal representation. Now the other case is when you have a non-terminating but repeating decimal representation. It is not it is not stopping after any place of decimal, but it will repeat. So this is non-terminating but repeating decimal representation, or we call it recurring decimal representation. So this will come when the numerator is not exactly divisible by the denominator. Again, it can be there in case of negative numbers as well, negative rational numbers as well. This will also have a non-terminating but repeating or recurring decimal representation. Yes, Somaya, I can remember. I hope that one is clear to every student in this session. Now there is one more thing called period and periodicity. Period and periodicity. For example, I've got a rational number like this. Suppose something like this, okay? And we put a bar over it. It means 368 is repeating. 368 is repeating. So over here, if somebody asks what is the period, what will be the period? So period is the number which is repeating. You got that? 368 is the period. The number which is repeating, that is called the period. And what about the periodicity? You call it periodicity or the length of the period. It means the number of digits repeating. So over here 3 digits are repeating, so the periodicity is 3. Is it clear? The number of digits repeating is the periodicity or the length of the period. Now suppose I'm taking some other example. For example, something like this. So what is the period over here? The number which is repeating, 8962. 8962, this is the period over here. And what is the periodicity? The number of digits repeating. 4 digits are repeating. So that is the periodicity or the length of the period. I hope that one is clear to every student in this session. So that is very simple to understand. Now one more thing you have to understand. See, For example, you have been given with this. See, this is a rational number because it is having a terminating decimal representation. So it's a rational number. So it must be written in the form of P by Q, where P and Q are integers and Q is not equal to 0. You must be able to do that. So converting this in the form of P by Q is very simple. You can simply write like this. If you remove the decimal, you know that 100 will come in the denominator. So over here, it's a ratio of two integers where denominator is not equal to 0. So when you have got a terminating decimal representation, for example, minus 3.286, something like this. So you can easily convert it in the form of P by Q, where P and Q are integers and Q is not equal to 0. Just remove the decimal, you will get 3 zeros in the denominator. So this is very simple. So converting a terminating decimal representation in the form of P by Q, where P and Q are integers and Q is not equal to 0, that is very simple. But suppose I give a question like this. Suppose I've got something like this. You see, this is not terminating, but it is repeating. It's non-terminating recurring decimal representation. So that is also a rational number, as we have seen in the previous slide. Non-terminating recurring decimal representation is also a rational number. So if it is a rational number, you must be able to convert this as well in the form of P by Q. Am I right? If it's a rational number, you must be able to convert it in the form of P by Q, where P and Q are integers and Q is not equal to 0. So how will you convert this in the form of P by Q? Can you tell me? Like over here, you cannot simply remove the decimal and you cannot tell how many zeros will come, because it is going on up till infinity. So you cannot decide that. It will be wrong. If it's a non-terminating decimal representation, non-terminating but recurring decimal representation, in that case, you won't be able to easily remove the decimal and you cannot say that this is the P by Q form that easily. So you have got some alternative methods for that thing. So actually there is a long method. When it comes in your school examination, you have to use that long method, and there is one shortcut as well. So we'll explain both of them in this session, right? So let us first understand the subjective or the long method. Like when it comes in your school examination, you must be able to do using that thing. Exactly. So you have to assume it. Suppose this is equal to x. So let us assume that this thing is equal to x. So x is equal to 1.444 and so on. Suppose this is equation 1. Right? Now can I multiply on both the sides by 10? If you will multiply it by 10, this decimal will move to one place towards right. Now you see one thing. There are infinite number of 4s in the decimal. So again you will get 4, 4, 4 and so on up till infinity. Is it clear? Is it clear, right? Now you might be thinking that why we are actually doing that. You will understand. You will understand once I will explain. Can I take equation 2 minus equation 1? So the left hand side minus left hand side, that will be 9x, and the right hand side minus the right hand side. So you see 4, 4, 4, 4 in the decimal and 4, 4, 4 in the decimal will be getting cancelled out. So decimal part will be 0 only and you will get 14 minus 1, 13. So basically the P by Q form of this rational number is 13 by 9. Is it clear? That is 13 by 9. Any doubt in that case? 13 upon 9 is the decimal representation, is the P by Q form of this. If you want, you can check it as well. If you want, you can actually divide 13 by 9. You will be getting this decimal representation only. Fine. Now you might be thinking that why we are actually doing this. I will explain using some more examples. Don't bother. Before that, let us do some questions on the basis of this concept. Fine. For example, I am giving one different question. And I put a bar over it. Can you convert it in the form of P by Q? Because this is also a rational number, so you must be able to convert it in the form of P by Q as well. Can you try doing that? So there is a shortcut for it as well. First understand using the long method, the subjective method, and then we'll be doing the shortcut method as well. Because many a times in MCQs, when you do a competitive examination, this question is asked. Like at 10th level, they ask this question most of the times, I would say. So you see, again, let us assume this to be x. So over here, let us write it properly just for us to understand. So you see 7 is up till infinite times, because you see a bar is there on 7. Bar is there on 7 over there, right or not? Now over here, can I multiply by 10? Let us multiply by 10. This will move one place towards right. So you'll get 25.3777 and so on, right? Second equation. Now understand one thing. Can I subtract over here easily? Let's see that, Anushka. Can I subtract over here? I guess no. Why? Because you see, this is going up till infinity. This is also going up till infinity. How can you subtract this thing from this thing? That is not easy. Like, it is not terminating. Are you understanding the logic? For example, you have got 5.1237 and you are subtracting 4.3289. So in this case, you can easily subtract. Why you can easily subtract? Because over here you can take the carryover. Now you know the last digit of it. You got my point? But over here it is going on up till infinity. So that will be very complex for you to understand that simplification. Are you getting that logic? Therefore, we are multiplying by 10 and all that to do this calculation. So for that, let us once again multiply by 10. So you'll get 100x. And then you will get, this will again move to one place towards right, 253.777 and so on. Third equation, right? Now again, are you able to see the same decimal form over here? No. Same decimal form is not here. Are you getting that thing? Again, you are having different decimal forms, na? So let us once again multiply by 10. So you will get 1000x over here. Now this will move to one place towards right. So you'll get 2537.777 because 7 is going up till infinite times. Are you getting that now? The logic? So now you can see that the decimal part is same. So now you can easily subtract. No problem in that at all. So this is, you can do equation 4 minus equation 3. Equation 4 minus equation 3. Left hand side minus left hand side, you'll get 900x. And then you'll get, you see, decimal part will be cancelled out. That will be 0 only. And then you'll get 2537. 2537 minus 253. Is that clear? So now you can easily calculate 2537 minus 253. So what are we getting over here? And then this is 2, right? So 2284 you are getting. 2284. So what is the value of x over here? X is equal to 2284 divided by 900. Is that clear to every student? Any doubt in that thing? Let us check the calculation once again. This is 4. Yeah, that is correct. Now you can further simplify it if you want. So you see 1142 divided by 450, right? Once again, you can simplify. So I guess this is the answer. I guess no further simplification is possible. Let us check if it is possible. No, it is not possible. So this is the answer. Is it clear, guys? Are you getting that? That why we are doing these things? There is a logic of doing this. It's not that without any logic, we are just multiplying by 5, or we are just multiplying by 10 or 100 or 1000. There is an absolute logic. Therefore, I'm taking this question over here. Because every time you'll not get these simple questions. You'll not get this simple one every time. You will get some complex ones as well, for which you have to understand the proper logic. Okay, that's good, Somaya. Okay, Anushka. Now, can you try doing this one? This is very simple, and I will explain the shortcut method as well. I'll explain the shortcut method as well. That was the subjective method which I was explaining. There is a shortcut to it as well. So if you know the shortcut, you can do like this. I mean, obviously, if it comes in your school examination, you cannot do it directly. You will not get full marks for that thing in a subjective, in a written examination. But when it is asked in an MCQ, multiple choice question, then you can easily do it if you know the shortcut thing to save your time. Because it's not just about getting the correct answer, it's about getting it on time as well. Yes, 7 upon 9 is the correct answer. Very good, Anushka. Let me explain the shortcut to you, okay? Concentrate on the board patiently. Suppose I've got a big number. Suppose, see, nobody will give you this big a number. Just understand that thing, okay? Nobody is going to give you this big a number. Suppose 1 over here, okay? But I'm taking a big example so that you may understand the shortcut. Now, what you will do over here, see this. Write the complete number. So that is 5, 1, 1, 2, 3, 6, 8, 9. Correct? Minus 5, 1, 1, 2, 3, 6, 8, 9. Subtract the number on which bar is not there. Subtract the number on which bar is not there. Is that clear? Divided by, on how many digits bar is there? On 3 digits bar is there, right? So 3 times 9 will come. The number of times 9 will come will depend on the number of digits on which bar is there. On 3 digits bar is there, so 3 times 9 will come. Now, on how many digits after the decimal bar is not there? On how many digits after the decimal bar is not there? So you have got 5 digits after the decimal on which bar is not there. So 1, 2, 3, 4, 5 zeros will come. You got that logic? So this is the shortcut method. Obviously, nobody will give you such a big question because this is a very calculative thing. But that is the shortcut thing. I hope it is clear. Somaya, Anushka, everybody else in the class. That was correct, Somaya. But understand this shortcut, okay? Because if you will understand this shortcut, you can do MCQs quickly. I'll give one more example. For example, you have got something like this. And you put a bar over it, right? How will you do this? Write the complete number 2537. Write the complete number minus the number on which bar is not there. The number on which bar is not there. Correct? Divided by, on how many digits you have got the bar. On 1 digit you have got the bar, so 9 will come. The number of times 9 will come depends on the number of digits on which bar is there. Now, on how many digits after the decimal bar is not there? There are 2 such digits after the decimal on which bar is not there. So 2 times 0 will come, right? 2 times 0 will come. So that is the answer. You can very well simplify that thing. So it is 2284 upon 900. I guess we are getting the same question. I forgot that. Okay, by mistake, I've put the same question. So see, are we getting the same answer? 2284 upon 900. Are we getting the same answer? Is that clear? So that is the shortcut. Any doubt in the shortcut, guys? Just confirm once. So that's how you can do it quickly. So for example, I have got 0.7 and I put a bar over it. Write the complete number minus the number on which bar is not there divided by, on one digit bar is there, so 19 will come. Now how many digits after the decimal are there on which bar is not there? How many digits after the decimal are there on which bar is not there? So there is no such digit after the decimal on which bar is not there, so 0 will not come. So the answer is 7/9. Is it clear, Somaya? Just confirm that. This is one of the important things. I'm saying that again and again. It will save your time many a times. You must be knowing how to do the shortcut as well, so as to save your time. If it is still not clear, then I will give one more question, one last question, and then we'll move on to the next slide. For example, you have got and I put a bar over here. Now, what is the P by Q form of it? What is the P by Q form of it? So again the same thing, write the complete number 1325 minus the number on which bar is not there, that is 13, divided by, on how many digits bar is there? 2 such digits are there on which bar is not there. So 2 times 9 will come. Now after the decimal, how many digits are there on which bar is not there? After the decimal, how many digits are there on which bar is not there? So only one digit is there, so 10 will come. So this is the answer. You can further simplify. This will be 1312 divided by 990. This is the answer. You can further simplify. This is the answer. I hope this is clear, and I guess it is not further simplifiable. This is the answer. Is it clear? Is it not clear? I hope it is clear now, Somaya. This must be clear. I'm saying again and again, it will save your time. I guess it is clear now. Okay, let us do some more questions. Like, can you tell me what is the P by Q form of this number? 0.9 bar in the form of P by Q. You can use shortcut method just to save your time, if you have understood that. Not able to understand that, Amar? Okay, Soumya. Game over. Okay, Abha. What is the P by Q form of this number? Can you tell that? Correct, that is 1. You can use the shortcut. So you see what you will do, write the complete number minus the digit on number on which bar is not there divided by, there is only one digit on which bar is there, so 19 will come, right? 19 will come. Now how many digits after the decimal is there on which no bar is there? So only no such digit is there. So therefore no 0 will come in the denominator. So the answer is nothing but 1. So what does it mean? That if you write 0.999 up till infinity, that is nothing but equal to 1. You got that thing? That is equal to 1. In the same manner, can you find the value of 1.9 bar? Can you find the value of 1.9 bar? So if you take 1.9 bar, write the complete number minus the number on which bar is not there, divided by, after on one digit bar is there, so 19 will come. Now after the decimal, there is no such digit on which bar is not there. So no 0 will come in the denominator. The answer is 18 by 9. That is 2. That is 2 only. So what does it mean? That if you have got 2.9 and you put a bar over it, this is 3. If you have got 3.9 and you put a bar over it, this is 4. So you have to understand this logic. Is it clear up till here? Any doubt to any student in this session? Okay, that's good. Anushka, Soumya, Amar, Abha. Okay. Now can you find, okay, before one more question, if you want proper guidance, proper career guidance, like what you want to do after grade 10 basically, and which stream to choose and how to prepare for board or competitive examinations, you can request a call back from our experts for any help. For that, you have to fill the Google form which is given in the description below, which is given in the description of this session. Like if you want any kind of career counseling, like maybe if you are confused that which stream to choose, what to do after grade 10, or maybe if you are there in grade 11 and 12 and confused, you can please request a session with our expert career counselor, for which you have to fill the Google form which is given in the description of this session. Like for example, if you're preparing for JEE 2025, you can again request a call back from our expert for any help, for which you have to fill the Google form which is given in the description of this session, right? In the same manner, if you are preparing for NEET 2024 or 2025, so again you can request a call back from our expert for any help, for which you have to fill the Google form given in the description of this session. So please don't hesitate and forget to do that if you want any help from our side, right? Okay, now you have got this question, you have to show it in the form of P by Q once again. Try doing this one. After this, we'll be talking about irrational numbers. Just convert it in the form of P by Q, where P and Q are integers and Q is not equal to 0. So again, the same thing, you have to write the complete number 0, 1, 2, 3 minus the number on which bar is not there. So you will get 0, 1, 2 over here, divided by, there is only one digit on which bar is there. So 19 will come. There is only one digit on which bar is there. So 19 will come. And then after the decimal, two such digits are there on which bar is not there. After the decimal, on only two such digits are there on which bar is not there. So 2 times 0 will come. This is the P by Q form. So this is basically 111 by 900, which you can further simplify. You see, so 37 upon 300 is the answer. Is it clear to every student in this session? Soumya, Anushka, Abha, Amar, any doubt in this question? So again, this type of question is very important. So we have already seen the decimal representation of a rational number. It can be either terminating or non-terminating repeating, which you also called recurring decimal representation, and we have done questions on the basis of them. Now let us talk about irrational numbers, and before that, you have to understand one feature which is there on the Infinity Learn platform, which you can use. There is one feature on the Infinity Learn platform which is very useful, which can be very useful for you. That is create your own test, CYOT. So what you can do on the Infinity Learn website, when you go onto the Infinity Learn app or website, so as to do that, you have to select the subject, then you can select the chapter, and then the question type, and then you can select the difficulty as well as you can select the time. Are you understanding that? I'm sure that this feature is not there on any other platform in the country, where you can create a test as per your own convenience. I mean, it's a kind of diagnostic test which you can make. Like it can be, the question type can be of your choice, the level of difficulty can be of your choice, and the time can be of your own choice, so that you can get yourself tested on that platform, right? So you can try. It's a very good feature and it is there on the Infinity Learn platform. It will be visible like that. So for that you have to go on the Infinity Learn platform, and you can please do that in any subject and in any grade, basically up till grade 12, JEE and NEET, right? For CBSE grade 11 and 12 as well, obviously. Right, now let us talk about irrational numbers. So irrational numbers, as the name itself you can see, irrational. It means numbers which cannot be written in the form of ratio of two integers. They are called irrational numbers. A number which cannot be written in the form of ratio of two integers is an irrational number. Alternatively, the definition is a number whose decimal representation is non-terminating and non-repeating. Non-terminating decimal representation and non-terminating, or you can say non-recurring decimal representation. Is that clear? So those type of numbers are called irrational numbers. For example, if I've got something like this, so you see nothing is repeating over here, no repetition is there. Like you cannot put a vinculum or bar like we were doing in rational numbers, and it is also not terminating. So this is an irrational number. It is neither terminating nor repeating. You got that logic? So any number of that form, it is exactly, I will explain that as well. Any number of that form is an irrational number which cannot be written in the form of P by Q, where P and Q are integers and Q is not equal to 0. So because it cannot be written in the form of P by Q, where P and Q are integers and Q is not equal to 0, you will not be able to find its decimal representation which is terminating or recurring. You will every time see it to be a non-terminating and non-recurring decimal representation. So 2-3 types of representation is there. The first type is this thing you can see, non-terminating, non-repeating. You see over here, it is not terminating and there is no repetition of same types of numbers. Similarly over here as well, it is non-terminating, non-repeating, non-terminating, non-repeating decimal representation. So all of these three are irrational numbers. You got that logic? Decimal representation is neither terminating nor repeating. So it will be an irrational number. Now there are other types as well. For example, you see square root of any non-perfect square number is an irrational number. For example, 0 by 3. Not able to understand that, Amar? 0 by 3 is a rational number. 0 is a rational number only, Amar, because 0 can be written 0 divided by any integer you can write. 0 can be written as 0 divided by any integer. You can do that. It will again be 0. So 0 is a rational number, right? Now square root of any non-perfect square number is an irrational number. For example, you take square root of a perfect square number. This will be 2 or not? This will be 2. So that is a rational number, na? Square root of any perfect square number is a rational number. That is a positive integer. You got that? But if you find square root of root 2, root 3, root 5, root 7, root 8, 2 is not a perfect square number, 3 is not a perfect square number, 5 is not a perfect square number, 7 is not a perfect square number, 8 is not a perfect square number. So square root of any non-perfect square number will be an irrational number. Now the question you might be asking, that how will you show that root 2 is an irrational number? So Yeah, that is correct. Whether it is prime or not, no problem in that, Somaya. For example, you see 10 is not a prime number, but its square root is an irrational number. It need not be a prime number. It must be a non-perfect square number. That's it. For example, if I take square root of 4 by 9 also, this is a rational number, right? This is a rational number. But if you take square root of suppose 4 upon 10, this is not a rational number. You can write it like this, 2 by root 10. This is not a rational number. This is an irrational number once again. Got that? Now you might be thinking that how and why these are irrational numbers. So actually one proof is there in grade 10, that is proof by contradiction method. I'm not taking that thing right now, obviously. It will take like 15-30 minutes it will take. But this simple explanation can be like this. You have studied how to find the square root by long division method in grade 8. Do you remember that? Square root by long division method. So if you will find the square root of 2 by long division method, you will see that its decimal representation will be neither terminating nor repeating. You will see that. Like square root of 2 is basically, as far as I remember, 1.414 something. It will never terminate, never repeat. You can check that. In the same manner, if you will find square root of 3, it is basically 1.732 and so on. It will never terminate and it will never repeat. I hope that one is clear. And so on, it will keep on going. So its decimal representation will be neither terminating nor repeating. And I have given you a hint how you can actually verify that its decimal representation is of what kind. Exactly. Okay, Soumya, that's correct. In the same manner, suppose you find cube root of a non-perfect cube number. That is also an irrational number. Cube root of a non-perfect cube number is an irrational number. For example, if I will find cube root of a perfect cube number, that will be 2 or not. If I will find cube root of 125, 125 is perfect cube number. So that is not an irrational number, right? These are all rational numbers. But you see over here, 2 is not a perfect cube number, 3 is not a perfect cube, 4 is not perfect cube, 5 is not perfect cube. So cube root of any non-perfect cube numbers are all irrational numbers. You got that? In fact, for nth root you can say, for example, you find the 4th root of 16, that will be 2 or not? Because 16 is 2 raised to the power 4. For example, you find 4th root of, I would say, 625, that will be 5 over here. So these are rational numbers, these are not irrational numbers. But for example, you find the 4th root of 100, that is an irrational number because you cannot get its P by Q representation. You cannot represent it in the form of P by Q where P and Q are integers and Q is not equal to 0. I'll tell that, Anushka. I hope that one is clear up till here. I hope that logic is clear to every student in this session. Right? Now many students think that pi is equal to 22 upon 7. That is the first mistake. Pi is not equal to 22 upon 7. 22 upon 7 is just an approximate value of pi for calculation purposes. Pi is not equal to 3.14 as well. Pi is not equal to 3.143. Those are all approximate values of pi for calculation purposes. You got that? Pi is an irrational number. Basically, what is the definition of pi? Pi is basically circumference of a circle. Although there are higher definitions as well, but obviously we cannot take other things like limits and all that. Circumference of a circle divided by its diameter, that is pi. Circumference of a circle divided by its diameter is pi. Now you might also be thinking, it might also be coming in your mind that, oh my god, circumference and diameter, so both are lengths. So one length divided by another length, how can it not be a rational number? Is that question coming in your mind? Please be honest. Because it used to come in my mind as well, right? That a length divided by another length, how can it be irrational? See, it will happen very naturally. For example, or maybe I will explain in a different manner. See, whatever may be the instrument you are taking, suppose you have got a circle and you want to measure its circumference, never ever you will be able to measure its exact circumference. Do you understand that thing? Never ever you will be able to measure its exact circumference. No measure is exact in nature. Whatever the instrument you are using now, never it is 100% accurate. Whatever the scale you are using, there is a degree of inaccuracy in that. Maybe if you use high resolution, the inaccuracy will be very small, but still it will be there. It means that you will never be able to exactly calculate the circumference, and you will never be able to exactly calculate the diameter as well. It is for 100% sure, right? Because there is a margin of error in every instrument. No instrument is 100% perfect. You say that it is having high resolution, it is better, that is another case, but it will never be 100% perfect. You got my point? So therefore, it will be an irrational number only. Or you can understand like this. For example, diameter is an integer or a rational number, then automatically circumference will be an irrational number. And if circumference is a rational number, then automatically diameter will be an irrational number. You got that? In nature, things will adjust like that. You got that logic? But the ratio of the circumference and diameter of any circle in this world will be equal to pi only. And pi is approximately equal to 3.14 and so on. 143 and so on. Nobody will be ever be able to find the exact value of pi. That is an irrational number. I hope that logic is clear. Like there are people and scientists and mathematicians who are trying since ages to find the exact value, like using supercomputers. Human beings are able to achieve that feat, that we are able to find the value of pi up till millions of places of decimal. But that does not mean that you will get the exact value, because it is irrational. Simple logic. Okay? There are various other complex methods as well so as to calculate the value of pi. We don't need to do that much in grade 9. I hope it is clear. Now, this is the third category of irrational numbers. You have got pi, and there is one number called Euler's number. Again, not going in the detail of that. Euler's number. There are other names of it as well. You can leave it. Euler's number, right? So these are other category of irrational numbers, and they are known as transcendental numbers. Now, what is transcendental? And basically, these are also irrational numbers. All of these are irrational numbers. These are called algebraic irrational numbers. So basically, algebraic irrational numbers are roots of equations having rational coefficients. Now, therefore, I don't discuss that in grade 9. So you can leave it for now. Like for definition, you can search on the internet, but don't waste that much of time. Right now, you can just understand that two types of irrational numbers are there: algebraic irrational numbers and transcendental irrational numbers. Oh yeah, that is there in grade 10, Somaya. That is correct. No problem in that. Okay? So this is grade 9 class, na Somaya. Therefore, I'm not taking that thing. Oh yeah, that's good. Yeah, because you might be there in grade 10 only. So I hope that one is clear to every student up till here. So that was all about discussion about the decimal representation of numbers over here. Basically, please don't forget to subscribe to the Infinity Learn class 9 and 10 YouTube channel. Please don't forget to subscribe to it. And there is Instagram channel of Infinity Learn by Sri Chaitanya as well, Facebook page as well, and on Telegram channel. Please don't forget to subscribe to the Telegram channel as well, because whatever is being discussed over here, that is shared on the Telegram channel in the form of PDF. So please don't forget to do that. And please don't forget to download the Infinity Learn app as well, because whatever the things which I had discussed, like create your own test, this thing of CYOT, that you can do on the Infinity Learn app. So please download it as well. And obviously, don't forget to like, share, and subscribe to the Infinity Learn class 9 and 10 YouTube channel. Okay? Okay, Soumya. So please don't forget to do these things. And if you have got any problem or any queries or anything like that, please don't forget to put in the comment section after the class, so that we will try to incorporate in the subsequent sessions. It's for every other subject, it's not just about me. Thanks, Somaya, right? And also tomorrow we'll be having a session from 4:15 p.m. right? So that's all we needed to do in this session, guys. We'll meet in the next session. Bye bye, take care everybody. I'm Misbah, your maths educator.